Hello, in this lesson, I'm going to review area under any normal curve. Right, that's section 7.2 of the lesson of your textbook. So same rule apply given if even where mean is not 0, standard deviation is not 1. But the data have to be follow a normal distribution. Right, so if normal follow a normal. Distribution. So let's do some example. Example 1, the age of a group of people in a racquetball tournament is normally distributed. I'm given normal, right? With a mean of 51 and a standard deviation of 3. What is the probability that a randomly selected person, one randomly selected person in the tournament is at most 48? Again, so let's draw what it's trying to tell me here. So I am given the score is normally distributed. So I'm going to write normal with a mean of 51 and a standard deviation of 3. Right? So the question asks me to find what is the probability. So probability, you represent that. A randomly selected person, her tournament score at most 48. At most 48. At most 48 meaning that no more than 48. So if I use X to represent tournament scores, so that means X have to be less than or equal to 48. So I want to find the probability that X is less than or equal to 48. Again, X here is representing the scores of tournament here. So at most 48 meaning no more than 48. So it's a keyword here. So let me put on my picture here. So what does it ask me looking for? All right, so let me zoom in a little bit. So mean of 51. Again, I'm going to draw X here first. So this X, there's a score. I'm not converting to Z yet, so just X. So I have mean of 51. So this is 51. Standard deviation of 3, meaning that I'm going to add 3 to go to next up, or I can subtract 3 to go down 1. So 48 should be somewhere on the left of 51. Right? So again, if 51 minus 3, that's 48. That's actually one standard deviation below the mean. So I say 48 is right here. Okay, that's your X. So again, I'm talking about X curve. Now, area at most 48 on the meaning at left of 48. So my goal is to find this area, right? The area on the left of 48, X equal to 48. Again, this is, so I can even show you the region. That's what I'm trying to find. All right, so we learned that a normal distribution means 0, standard deviation 1. Actually convert that to standard normal. Right? So I'm going to draw another line here to represent standard normal. I'm going to call it Z, standard normal Z. It means 0 and standard deviation 1. And so now I'm going to convert that 48 to Z. I want to know what is that equal to in terms of Z. Right? So once I find that, I can use a standard normal again like we did in 7.1 to find the probability. So step 1, let's convert that to Z. So recall Z is equal to X minus mu over standard deviation. X is the score of one person there, this is 48. Mean is 51, standard deviation of 3. I subtract that, I got -1. What that means is if I draw a normal curve, this one line over here, that is a -1, which is my Z, right? -1. So I'm looking for the probability that on the left of Z, and again, I'm using the same normal curve here. So probability of X less than or equal to 48 this is equal to same probability of Z less than or equal to -1. Right, I'm using red here, -1. And we say for find probability, we use normal CDF. So normal CDF. Lower bound in this case is -999, negative infinity, we represent that, up to -1. So -1, it means 0, standard deviation 1. And you want to put comma onto it, okay? So enter that in your calculator, and you get approximately 0.1587. Right. Now we can answer the question in a complete sentence. I say the probability that a randomly selected person in the tournament have a score at most 48 is 0.1587. You can also interpret in a different way using proportion. I can say that the proportion of tournament score that is less than 48 is 15.87%. Right? So that's just answer the question in a complete sentence. Again, notice that this is almost exactly the same as 7.1. The difference is here, now I'm not given standard normal anymore. I say I don't have mean 0, standard deviation 1. I have mean of 51, a standard deviation of 3. Now the sigma here 3. And then I convert that score into a z. I convert the x to a z, and then I use that to find the probability. That's one method to do it. This is method 1. And that's the one way that we did in class. Right, this is how we did it in class. Now I'm going to show you a different method. Some student approach me and say, can I use this method? Oh, I said no earlier, so you know what? Do it, it's fine. If you know how to use that method. Let me show you. So method 2. Right. For method 2, I don't really need to convert to z, as long as given normal distribution with mean and standard deviation. Notice that I can write it again if I want. So all I have to do, put in my calculator. Again, if we convert to z, you could use your table to find the probability. But without converting to z, if I use a calculator, I can just do it directly, use the calculator without converting. All right. So this is a method without converting. So I'm going to do is the probability of x less than or equal to 48. I'm going to do exactly the same thing using normal CDF. Right. Now here, my lower bound here is less than 48. Things are under 48 on left tail 48. So my lower bound is still negative infinity, negative 9999. I can put even one digit more if I like. And my upper bound here is 48. Now be very careful here. My mean and standard deviation is not 0, 1 anymore. My mean is 51. And my standard deviation here is 3. Right? Note that I am using this one over here. I mean, I'm not using mean 0, 1. And enter that in your calculator, you should get the same answer, which is 0.1587. Let me show you both on a calculator so you can see side by side. On your calculator, let's do the first one where I convert to z. So second vars, no more CDF, which is number 2. And my lower bound was negative 99999. I can put more digit if I want. Again, it doesn't have to stop. It just, because I'm entering a calculator, it doesn't change my answer. My upper bound is negative 1. Mean is 0. Standard deviation is 1. I could just do that. Notice that my answer is 0.1587 approximately. Now let's do the one without converting to z. Right? So second vars, number 2. And my lower bound still negative 9999. And my upper bound here is 48. I'm putting a value of x here now. I'm not z. And then my mean here is 51. My standard deviation is 3. Right? So enter that in my calculator and I would get the same answer. Right? So both approaches would help you get an answer. Now, method 1, once you convert to z, you could give you the option of use a table to find your answer, where option 2, we don't have a table for it. So I would say either method is valid. You can use either one. Right? So that's this example. Oh. So let's do another example. Okay, now in this example, I'm also gonna do it in 2 different methods again, using the converting to z and not converting to z. So let me draw a little separation here, so that way I'm not confusing. So first method, let me draw a little better. It's very hard. Actually, it's hard to draw a straight line here. So let's read the question. A study found that the mean amount of time cars spent in the drive-thru of a certain fast food restaurant was 153.2 seconds. Assume drive-thru time are normally distributed with a standard deviation of 33 seconds. So we are given that normal distributed. So notice that driving time is normal. Right? So I can write it out. So as I'm given normal, with a mean of 100 mu equal to 153.2 seconds, where the standard deviation is equal to 33 seconds. Right. Right. Part A. What is the probability that a randomly selected car will get through the restaurant drive-through in less than 104 seconds? And notice I want to look for less than, right, 104. So let's do my drawing. So my mean here, again, let me draw the x first. This is my x, given x with a mean distributed. X represent the driving time, the time spent in drive-through, right? So I want the mean here is 153.2 with a standard deviation of 33, and I want less than 104 seconds. Let me use standard deviation here. I'm gonna use the same for both z, so I'm not gonna label it. All right, let's just do 104. So 104 have to be on the left of 153.2. So that's my 104. Again, remind yourself this year on in the x here, I haven't converted to z yet. Less than 104, that meaning I want an area on the left. So I'm trying to find the probability of this part here, this region. So we say find probability first. Method 1, we say to convert to z. So step 1. So I say z is equal to x minus mu over standard deviation. X here is 104. My mean is 153.2 and standard deviation is 33. Convert that, we'll get z is approximately equal to, and I want 2 digits, that is a negative 1.49. Right, so meaning that now I can draw another curve just right below it. There's a z that is negative 1.49, and remind myself z has a mean of 0 and standard deviation 1. Okay, so now I can find the probability. So I want to find the probability on the left of z equal to negative 1.45. So I say probability of z less than negative 1.49 is equal to normal. That's step, not this step 2 here. This is step 1, step 2. Normal CDF. My lower bound here is a negative infinity or negative 9999. My upper bound here is a negative 1.49. I'm converted to z already, so my mean is 0, standard deviation is 1. You can enter that in your calculator, and we'll get approximate the answer to 4 decimal place. So that's approximately 0.0681. Right, so that's my answer. So I say the probability that a randomly selected car will get through the restaurant with a drive-through in less than 104 seconds is 0.0681. Right, so that is method 1. Right, so in the second method, I'm gonna do it without using the converting. So without converting, again, I'm still using the same normal curve, and I say, well, I want to find the probability of x less than 104, so less than 104 second, right? So less than 104, I'm still using normal CDF. Now my lower bound here is a negative infinite, negative large, negative number, right? Using the area here, left tail, and my upper bound here is 104. Now my mean here is not 0.1 because I didn't convert to 0.1. So I have a mean of 153.2 seconds with a standard deviation of 33. Right? So type that in your calculator. You will get the same answer, which is 0.0681. Alright, let's try that on your calculator for both of them so you see the exact same answer. Okay, on your calculator, let's do it. So I'm going to do the one that converts to z first and do the other one followed by that. So go to second vars, go to normal CDF. And my lower bound is negative 999. My upper bound here is negative 1.49. That's my z-score. So z has a mean of 0, standard deviation 1, standard normal. And enter that in my calculator. And I get 0.0681 approximately. Now let's do the one without converting. So second vars, number 2. I'm going to go to negative infinity, or represented by negative 999. Without converting, I might even make it even larger negative because I'm not converting. So negative 99999. Again, but without adding 19 here, should not change my answer at all. But I'm just going to put a negative number to be safe side. My upper bound here is 104. My mean here is 153.2 seconds. My standard deviation here is 33. Okay, enter my calculator. Notice that my answer here is a little bit smaller than the previous one. The reason is that if I convert to z, notice that the z-score here is approximation. It's not the exact z-score. Approximate using 2 decimal places here. Right? So approximate once already, so therefore the answers here not as exact as if I would do without it. So both answers here are valid. Again, this one here, I'm using z, approximating z, and this one here, there's no approximation for z here. So, but if I want to round it to 4 decimal place, my answer will be 0.06A0, right? Not A1, A0, right? So let me change that. This should be A0. Okay. Again, this is without converting to z. So either method will give you a answer. But if you using this method too, just write down what you input in your calculator so I know that you're not converting to the z. Or you do z and write down the exact function as well. Right? Either way is good. But I'll say the first method, once you convert to z, this allows you to use your normal table to find the probability without using a calculator. Right? But if we do using a calculator, either method, I would say method 2 will be easier if we just do calculator directly. I'm skipping B and C. I'm going to go straight to 3. Hopefully this will help you do some of your homework problems. So part D says, would it be unusual for a car to spend more than 3 minutes in the restaurant's drive-thru? And let's recall that our mean and standard deviation again is that we say the normally distributed with mean 153.2 seconds, standard deviation of 33 seconds. And you notice that this one is given in minutes. So first thing, before I do anything else, I want to have more than 3 minutes. I want to convert that to seconds so that way that I can do my answer, right? So let's convert to second. So 1 minute equal to 60 seconds. So 3 minutes going to give me 180 seconds. Right, so that converted to x equal to 180 second. That's why it's important actually to write down the given information, read it a little bit carefully, so that way notice that, make sure it's actually using the same unit. All right, mean is 153, so the middle here this is 153.2 seconds with a standard deviation of 33. So 180 should be somewhere all the way over here. This is 180. Again, I'm using x here. This is x. So I want to find the probability that the car more than 3 minutes. Well, if more than 3 minutes, meaning here, I'm looking for here. So what is this part here equal to? Right? What is the probability that a car spent more than 3 minutes? Now, here, unusual, let's think about unusual. We say case is considered unusual, we use 0.5%. We say if the probability is under 5%, it will be considered unusual. So let's find the probability. And let's write it. So here, I'm on probability of I'm going to find it using the z or without a z. This here, I'm going to do z by method 1. So first, I'm going to convert to z. Z is equal to x minus mu over standard deviation. My x here is 180. Mean is 153.2 with a standard deviation of 33. And you convert it, you get I'm going to keep 2 decimal places, approximately 0.81. Okay. Now, to get that here, so now I can find the probability. So probability of, before I find it, let me draw one more line to represent z. Right. So I'm going to represent z here. And this is my z curve. Right. And z with a mean 0, standard deviation 1. And that is z is 0.81. I want area on the right tail of z, so I want this part same thing as before. So the same as probability of a z greater than 0.81. And that is equal to normal CDF. Lower bound is 0.81. Upper bound is a positive big number, we represent infinity. I'm going to put 999 and 0, 1. And put that into your calculator. You get approximately 0.2. Oh, this is point probability to be a number between 0 and 1, not 2 point something, 0.2090. So notice that since this probability is more than 5%, which is greater than 0.05, so therefore this is not unusual, right? To see someone spend more than 3 minutes in line, right? It's not unusual because more than 5%, right? So this is problem D. Let's do one more involving percentile. Right, the score earned on the math portions of SAT, a college entrance exam, are approximately normal. Okay, I'm given normal here, so I can use the normal distribution with a mean of 516 and a standard deviation of 116. What score separate the middle 90% of the test taker from the bottom and top 5%? Okay, so let's draw it and write down the given information first. So I'm given normal, so I'm going to write normal. Distributed with a mean of 516 and a standard deviation of 116. Now, I want to score the middle 90%, the separate the bottom and top 5%. So, okay, so middle. And here. Again, I'm drawing X here. So here I'm looking for this 0.90. Again, here X is Z doesn't really matter much yet, but I'm going to draw a Z below later. So let's just do it. So this is 0.9. Oh no, actually this is not Z. For X and Z using the same curve, but here I could label X. I label Z as well. Again, think about probability. Z is 90%, top 5%. It's just probability, 100% under 1. So it's the same, right? Probability here, whole thing is 100%. So I'm going to write this is 0.9. Okay. And meaning that the area in each tail here will be 5%, 0.05. And here also 0.05. Now, I can use this curve to find Z. I will get Z1 and then Z2. But think about it. I'm looking for a score. I'm looking for X. So I'm going to use the Z score. Once I find it, I'm going to convert to X. So with X1, X2. So there's two steps involved here. First, I'm going to find Z. Then I'm going to use that Z to find X. Okay? So let's find my Z first. And let me draw. This is my X curve. So this is X here. All right? So let's write it. So first, I want to find Z1. Z is inverse norm. So I'm going to use inverse norm to find Z1. So Z1 is equal to inverse norm. Lower bound is negative infinity. Oh, not lower bound. I'm thinking of probability now. Inverse norm, give me area on the left of Z1 is 5%. So 0.05. And mean is 0. Standard deviation is 1 because I'm looking for Z. And if you do that, put that in your calculator, inverse norm, you get negative 1.64 approximately. And by symmetry, I know Z2 should also be positive 1.64. Now, I'm going to convert that Z to X, right? So I say X1, X, again, remember X is equal to mu plus Z sigma. Right? I will recommend you watch the first video. We'll teach you why this is a formula. So plug it in. So my mu is 516. Z1 is negative 1.64. And sigma is 116. And calculate that is approximately 326. Right, the score. And X2, mu plus Z sigma, right? And the Z score for Z2, again, I'll make sure I put a Z1, Z2 here. I'm using Z1 here, I'm using Z2 here, right? So that gives me 516 plus Z2 is positive 1.64, 116. Plug that in your calculator, you get approximately 706. So the score that separates the middle 90% from the top and bottom 5% are 326 and 706. That means 90% of people score between 326 and 706. All right. Thank you for watching the video. I'll see you next time.